Ladies and gentlemen, it is already time for our first quiz. My, how time has flown. So, normally when we're in class, we will work through parts of this review together. I will either have you in groups, or I'll have different people present for points, or we get some sort of a review activity going. But for online purposes, I just kind of get down to business, talk through things, make sure you've got a good idea of everything that is going to be on that quiz, and then take it from there. So, first thing I'll answer, because it's usually the first question I see as we go. Hardy, what are all these little boxes out of 5? Um, there are some teachers that still do standards-based grading and grade on a 0 to 5 basis. I am not one of them currently. So I leave the reviews alone when it comes to that in case that changes in the future. But for now, I just want you to be acing everything. So 1-1 evaluating expressions of x equals 3 and y equals -4, evaluate each expression. I'm going to do this right on here. I'm still a big fan of parentheses around stuff like that and working that through. So when we are going through here, number 1 is 7 times x plus y. Now, here's an interesting thing to ponder. I will have some people who, right off the bat, Hardy, I'm going to put everything in its place like this. Then I'm going to plug that into the calculator, or I'm going to do this in my head. 3 plus -4 is -1, and then I'll multiply them, and I'll go. That is absolutely a terrific spot-on mathematical way of doing it. I do have people ask me every time, though, that we do something like this. They're like, well, wait a minute. Could I take that same problem and distribute the 7 through, then plug the numbers in? And the answer is a resounding yes. Again, math gets this bad rap that it is one way, the only way, this is what it is, and you can't do it any other way. And that is completely false. 21 plus -28 is also -7. So you do which way is going to make most sense to you. Now, next hurdle to make sure we don't get buried by. Whenever you are squaring something, okay, anything to an exponent, you are going to want to use parentheses, because as we have discussed before in other videos, if you don't use parentheses, especially with a negative, it's going to cause you a problem. It is going to get us back into this situation again. With parentheses gets you a different answer than without parentheses. You can't even see my negative in there from before. That was bad. So now, whether I use the calculator, my brain, whatever, I'm not going to have a problem, because negative times negative is positive, and 3 squared is 9, because again, 3 squared means 3 times 3, not 3 times 2. We add them up. Last twister possibly on you here. So you're like, ooh, man, he's not being like the nice little layup ones here. Number 1 wasn't bad. Number 2 could have had a twist. Number 3 can be outright bad. Because when we have a big fraction, we need to use parentheses on the top, because even if you plug in numbers and type them correctly into the calculator, you're probably going to get the wrong answer, because the calculator is going to want to divide before it does this, and that's not what we want. So we have got 3 times our y value minus our x in parentheses. Wow, parentheses are us. All right. Could I type that directly into my calculator? Yes, exactly that way. It'll work. But if we're not, and I'm not going to here, because as you can see, I don't have a calculator in front of me, I'm going to go ahead and crank this out. So multiply comes before subtract. So 3 times -4 is -12. minus 3 over 5. Still in the parentheses, so I still got to keep working here before I divide. That's why we did it. Negative 12 divided by negative 3 is negative 15 divided by 5. And now that I've done all the math work in the parentheses, now I can drop them and divide that out and get my answer. So that's our evaluating expressions. We had a couple of interesting little notes in there. Okay, translating each expression into an algebraic equation. Okay, 4 times a number, again, a number is pick your own variable. 4 times a number plus 9. Now, you're like, Hardy, is it this? You know the Post-its are coming back. Or is it this? Or does it even matter? Let me answer the last question first. Yes, it matters. You're going to get 2 different answers with these. Oh boy. So here's the thing. Do you see the word sum anywhere? A sum of a number and 9. No, I just see a number plus 9. 4 times a number, so 4 times x plus 9. Okay? Unless you see sum or difference, you do not have to do that. And you wouldn't want to do that in this case, or it's not going to be right. Speaking of, hey, what a coincidence. 5 multiplied by the sum, parentheses, of 2 in a number. Sum is plus 2 in a number, 5 multiplied by that. I have to have the parentheses this time. That's how I tell the difference. No pun intended, okay? Sum and difference, we use parentheses. The other stuff, it's not going to be as necessary. Okay. A number squared. Ooh, do we remember what that is? A number to the second power divided by 4. Or a number squared divided by 4. Either one of those is fine. Fraction bar, writing it that way, you're good. That's it. Yeah, I know, nothing fancy on that, nothing tricky. No. Twice 2. Difference between a number and 1. Twice, 2 times the difference of a number and 1. Magic terms right there. Okay. All right, couple of applications here. Adonis is going to the fair. It costs $5 to get in. So it does $5, okay. And $2 for each ride. I'm going to use R because it's ride. Plus $2 for every ride. Now, and again, when you write it, think it through for a minute. You're like, okay, I'm out $5 no matter what. It don't matter. If I ride 3 rides, it'd be 2 times 3. If I ride no rides, I'm just walking around, hanging out, and socializing. It's 2 times 0. I'd still pay the 5. And figure that out. But again, per, each, those are key words to get you thinking about, hey, I need a variable with this. And you use whatever variable you want. I'm fine with that. So again, here, the temperature is 75 degrees. All right. And is dropping, getting less at a rate of 5 degrees per hour. I'm just using X this time. So for every hour, it's getting 5 degrees less. Well, I hope it stops dropping sometime. It's going to get kind of cold. But again, just kind of thinking through that a little bit. You're like, Hardy, is this about the length of the size of the quiz too? That's a good question, and it's usually going to be in the ballpark. It might be a couple questions less. Usually it's not going to be more, but I'll tell you that in advance. But that's an in-class thing, I tell you. So be in class. All right. Finally, 1.3 are 2 days of combining like terms in the distributive property. Simplify the expression. All right, I don't see any parentheses. It's just find stuff that's alike. Watch the signs. Combining like terms doesn't mean it always gets bigger. Okay, 2 minus 10 is -8. And with my b's, ooh, now here's another good one to talk about during this. 5b plus b. You will be shocked at the number of people that would tell me on the quiz that is 5b. Because they're like, well, I don't see a number there. If you don't see a number in front of a variable, there is always a 1 there. Always. So this is 5 plus 1, which is 6. So see, now you're not going to get into trouble because you were paying attention to that. And you get to see it again in number 11. So hopefully you do number 10 right, because otherwise number 11 is going to be just as big of a problem. 6 and 12, 18x squared. Again, there's a 1 there. 1 minus 9, because we're watching, is 8. Are those the same? Can I put these together and call this 10x squared? No. That is x squared. That doesn't. As far as you go. Got this. Almost there. Parentheses. We're going to distribute. Distribute means multiply. 4 times x is 4x. 4 times -9 is -36. Not the same. Don't go any further. And I would say in this particular small area that we've got here, the biggest possible downfall is this first thing again we're seeing here. -5 times 6 is -30. You got to remind yourself somehow, I got 1, I got 2 x's, x squared. Okay. -5 times -1 is +5x. Not the same thing. This is more about attention to detail. Do I remember to keep the x on the one with the 1? Do I remember that there's x squared when the second one is there? That's going to be the question. Because now we get to combo number 12 and 13 into a big one here in 14. Patience. 3 times x, 3 times -4. Over here, -2x times x is -2x squared. -2 times 7 is -14x. And now again, when you go to combine like terms, be careful. You're like, okay, 3x. There are, ooh, right there. I was about ready to say there are no other x terms. Yes, there is. It's right there. So 3 minus 14 is -11. Are there any other just plain old numbers? No. And are there any other x squareds? No. Now, if you were looking at my answer key is probably going to be -2x squared minus 11x minus 12. Because what that's called is writing your answer by decreasing degree. That's what we normally do in math books, other things like that. But here, I'm most interested that you've got the right terms with the right numbers. If you have them in a different order, I'm fine with that. Okay? Last one for the review. Don't get sucked in. Multiply comes before add. Do not add those first. Multiply first. Distribute first. 4 times x, 4 times 2. Find the things that are alike. Put them together. Call it good. If you're good, if you walk through that and you're like, hey, I'm feeling pretty good. But before I was telling you all the answers, you're probably in good shape. If you need to, if you're a little bit longer of a studier with things like that, if there's any problems you haven't finished in the other assignments, go back and do them. Maybe you even grab a few of these questions. You write the original questions down and see if you can do them now, and then use this as your key. But let's get off to a good start with this. And as always, if you've got any questions, let me know. We'll see you.